we matured enough to reduce the load, reduce the impact towards the environment. So always for any so for you, many of your industrial practitioners, many of your students, many of your future. So that is where the goals means there is principally see UNAP, United Nations environmental programs are there. Under that, each country has agreed to reduce, for that matter, greenhouse gas emissions. So India is also by 2050, if I'm right, they have said from greenhouse gases we have reduced around 30-50% are moving towards the renewable energy consumption. Like this, any sustainability goals, it has a objective to meet. So we are abide by the regulatory compliances. Even for that matter, the institutions, universities are governed by the NAC, National Assessment Accreditation Council. That's how this Mukta Mohotri is being assessed for environmental performance and also for learning and also for the other activities or promotional activities and accredited as a A+1. That's how for industries also we are all governed by the Government of India rules, Central Pollution Control Board rules and also the State Pollution Control Board rules. Apart from there are many rules also like Bureau of Indian Energy and also the greenhouse gas emissions conference to the bodies. For any initiatives, any activities taken for the improvement, obviously there will be a cost involved in it. In this discussion also we heard that if you invest for any advanced technology, there will be an initial investment, but also it will attract a cost. So cost you cannot afford it initially, but if you see that its benefit or payback after then continuously it is saving, obviously it is required. And also where it is linked, the regulators will come, they will instruct sometimes you have to install this technology to reduce from this target to this target. So that's how these cost savings also will come by force, by enforcing these laws. By enforcement of these laws, we are binding to get savings indirectly, intangibly. Ultimately, what it will create? It will create a reputation branding. Like A plus grade means the university is good, overall learning, growth, opportunity is good. Like that, even for industries also abide by many standards, many management systems, like ISO 9001 quality system for the product which they make from raw material to till the finished product, till the consumer use, and also what impact in terms of environment it going to create from raw material usage to till the waste management, and also like energy consumption, utilization, those things. Many of the branding it will create. So suppose world class, you're also whenever you wanted to buy any product for commercial use, for the household usage, or for that matter, for any commercial activities, you will see the what technical specification behind it. It is energy saving, it is giving a impact in terms of savings. So those things it will give for academic purpose. Suppose if this campus is, I heard that Chandrasekhar also mentioned that this campus is accredited by NAC for green audit. So means the activities, initiatives, whatever the Mukta Ngodria, the Karnataka State Open University have taken, that is well matured enough, and they also accredited for A plus rating. That's how this reputation and branding for altogether will come. This we have discussed just now. Like background, green audit means green audit and environment is similar, both are similar. Only thing is conceptual wise it is different and the mode of operation is different. Green audit for campus or the university or institution also work in the principle of plan, do, check, act. Like even ISO systems also work in plan, do, check, act. So it is governed by the NAC, National Accreditation Assessment Accreditation Council, and also ISO 70,020. It is the guideline how to rate the university or how to rate the campus or the initiatives which are taken. So that directive is written in the ISO 17020. And from this, whatever we discussed already, the major purpose is to reduce the impact and also making the sustainability improvements and initiatives to get going, and also reducing the overall health risk and creating a world-class atmosphere or learning atmosphere for academic purpose or in terms of practices. That is also giving a world-class platform to work better in terms of safety, health, and environment. Green audit also will help us to find out or else to deep dive into where in terms of natural resource conservation or mitigation or the any improvements. And for the university, it gives a branding. That's what we have discussed already. And also if this campus is built in a busy industrial site, could you able to imagine? Can you able to go through that pain in terms of noise, in terms of dust, in terms of disturbances? So because of flora and fauna built around it, you can able to peacefully, happily, with pleasure, you can learn whatever you wanted. The future for betterment. There are various types of audits. One is green audit, that what we discuss now. Another one is energy audit. Just before this, there was an energy audit. Energy is also one of the major area because energy plays a vital role because it cannot be seen, but it is having a vital role. And environmental overall performance. And what it will give? It will give a reputation and recognitions that we have discussed already. In the bottom line, you can see that I have mentioned that green building certificate. So green building certificate is nothing but if you are giving this, if we taken this auditorium itself, if you are allowed more ventilation to come in, more natural lights to come in, and less commercial, be it industry, or be it overall nationwide. So what is the current trend in terms of energy management? So now it is the ESG. ESG means environment, social, governance. So in that also, power purchase agreement. So now leasing or wheeling of power. So wheeling means natural power generation. For example, we are into sectors of renewable energy and also solar, also renewable energy. If the solar energy, wind energy combinedly, there is called as hybrid energy, and that is wheeled to the conventional grids, means basically for the BESCOM or the CHESCOM. From CHESCOM you are getting, that is also comes under scope 2. Scope 3, which you don't have control, you can only influence for contractor services, contractor activities, or you hired some DG for some purpose for some period of time, or you can rate it as my specification for this DG energy consumption should be this, and I did a desired output. Like this is further subdivided, scope 1, 2 and 3. Waste, many of you know, waste 3R principle and also the polluter pay principle. Means we are abide by the regulatory, also by the law. Whatever we can reduce from the source or from the point of use, we should do. If not, the whatever we generated, we should manage scientifically, technically, and it is a less impact to the environment, and it should be disposed to the authorized stream of treatment or the authorized persons. And using latest technology, there are multiple technologies evolved. Treatment of water, there are RO, UV, those things, even for wastewaters, multiple effector evaporators, and there are many more things are there. So importing those technologies will help us to reduce the burden on for our commercial usage or for our industrial usage, to run a factory or to run an institution or to run a warehouse. It can be warehouse. So how we handle the water conservation means, so the major thrust we have to give on the natural resources and also the reduction on conservation. And suppose if you are trying the more water, how we can save it, how it can be recycled and utilize it for our gardening purpose or land use purpose or the landscaping purpose. These are also key components in terms of resource efficiency. Means the whatever we discussed, resource like natural resource, how better we optimize our resources and how our controls are effective, how best we are utilizing in terms of, there are many terminologies coined now, water neutral, water negative, net zero, zero liquid discharge. Those are all comes under resource efficiency. Carbon footprint assessment, basically a greenhouse gas emissions. It is more of a tabulation, means like what I mentioned earlier, the scope 1, scope 2, scope 3. The every natural resources or every energy we use, there is a amount of energy, there is an amount of impact to the environment in terms of CO2 generation. So there is a that we have to tabulate it, and many technologies came, because suppose if you are getting a power from wheel sources means from solar or like a wind, your conversion factor or the leakages or the generation, the amount which the carbon dioxide getting to burnt, so that is less compared to conventional energies. These are all steps. It is part of all the ISO system. First, any audit, any assessment, we should plan, we should prepare. Means what is the baseline, current state, where we are standing in terms of environmental performance. So you have to define the area, scope, that is called a scope. Suppose if we wanted to do environment audit or assessment for this auditorium, this is the boundary. So in this boundary only, we have to assess ourselves for the data collection. How much electricity we are consuming per day, or number of students, or number of hours, like that. And there should be inspection records, and there should be monitoring. And from this, we should analyze, evaluate ourselves. Is there any chance for improvement? Instead of using these lights full day, can we allow natural ventilation or natural lighting, wherein we can reduce the electricity consumption, we can reduce our requirement. And finally, report and submissions. So reporting and recommendation means, reporting means current state, and recommendation is future state, means you have opportunity for improvement. And there will be follow-up. This methodology followed in all the ISO systems: plan, do, check, act. I need not to go on this, actually you know better than me. Impact assessment means overall assessment. Any project, any initiative which is related to environment, it calls for the impact assessment. And life cycle assessment. Let's consider our example only, as an example only, our industry. Suppose if we are making a blade, so what is its lifestyle and a lifespan? What are the raw materials used for the making of the blade? And how we are managing our waste? How we are disposing it? What is the impact of utilization of these natural resources in terms of raw materials, and also letting as a waste into environment? So overall, what is the reclamation or overall impact to the environment? That's calls for life cycle complete, means cradle to grave. ISO 14000 is a system, and it covers overall AMS management systems. Like in last session also you heard that energy management system, there is a latest systems, like you can sit at one corner of the building, you can control entire campus through SCADA. Means it's more of a monitoring and also taking control of wherever the consumption is going peak, less, any variations. So those technologies are evolved now, and not only for the industry, even for IT, even for commercials, even it can be your household. Through Alexa, you can control your energy at your home by switching on, switching off. That is also technology which is advanced now, for the benefit of cost as well as all the impact, overall impact on the environment. And we should adopt sustainable supply chain model. This is one gray area, because in industry we talks more on the supply chain model, because from start to end, identifying the supplier, easy, qualified to do authentically, give right product, right raw materials, easy practicing right approaches towards the handling of the raw materials, adhering to the requirement of the regulatory standards for environmental management system. Those kind of things will come in pitch here for supply chain model. Carbon footprint overall, that we have discussed already. So this is one of the major area, like in every audit or every assessment, why we will not easily go for it, because there are some challenges also. One is cost. First one is cost, because you have to hire an auditor, you have to maintain your resources, you have to invest some part of as a cost for deploying these activities, or manning the people, or involving the external agencies, or taking approval, or approval for the certifications. Sometimes you buy some instrument which is not as per your rated capacity, but again you wanted to upgrade it to meet the standard. If not, you will not get a certified. So those times there will be cost implications. And data availability, there could be if it is manual, that can be a data mismanagement also, that will lead to your benefits will come down. It will not impact more, but it also impact probably if it is a major regulatory one, your certification will get old, or you will be given negative remarks in the market, or sometimes your audit scores or assessment scores will come down. Sometimes we also show resilience. Resilience is nothing but we require. Suppose if in industry, as being an industry practitioner, suppose if I go to talk to my management, probably the first instance they may resist also, because of the first two, means cost, also the who will monitor, who will take the lead. So sometimes this resilience factor also will come. So but by taking overall consideration, making our objective is clear set, and what is the benefits we will get, the resilience factors can be omitted, can be resolved. And also sometimes there is a complexity of regulations, nothing but understanding. ISO 14001, same clauses for my activities, I'll understand in my own way. For the same clauses, for the same set of activities, as an auditor, they understand differently. Because as an auditor, they would have seen many best practices, many improvements area. But whereas additive, probably my scope of understanding or the expertise will be very low. Like this, there will be complications with respect to regulations also. These are all some of the reference standards. It is a common for green audit or environmental audit. First one is on the green building. So the CA or the Bureau of Energy will have this code of rating system. And energy, like Bureau of Energy already mentioned. And ISO certification, whatever I mentioned there, we all as an industry, we have all these certifications, be it a quality management system for our product, ISO system for ISO 14000 for our environmental best practices, and occupational health and safety system for overall employee welfare and being, and also considering the industrial hygiene practices. And food safety management, we do run a canteen round the clock for serving our employees. So that is food safety management. And ENMS, just before this session, there was a ENMS, because whatever initiative we have made, so that is certified under ENMS, Energy Management System. And waste, these are all audits, different audits. And carbon footprint, there is a guideline for 14,067, which is revised in 2018. And water footprint and water efficiency under 1406 2014, and ISO 46001 under 2019. Some case studies, it's a general. You can take a note. Toyota. If Toyota decides all their units to be energy efficient, or all their manufacturing units to be energy to be reduced from 10%. That is a objective. They will give a direction to all units. Then obviously they look for the opportunity how to reduce where and all they have a opportunity to reduce the energy. In terms, it is a benefit for them to manage the overall environmental impact in a positive note. This is Nestle chocolate manufacturing. If they now decided to conserve their water consumption or water management system, so probably they'll look for new technologies, advanced technology in terms of from generation point to till the water treatment plant, installing the water flow meters, the new technology type, leakage erections, and also utilization of treated water for gardening or land use purpose. This is related to Google, IT, basically carbon footprint, because Google is the service supporter for all the clouds. They are more into CPUs, technologies, transmissions, data transmissions, uploading. So whenever you send a mail, there is always a carbon emission, energy loss. So those things, if they take as an objective, they can achieve it. Here some of the examples, case studies. AHU already they have mentioned. This is I'm referring to one of the industries, water conservation. You can see on the water conservation, the condensation water from AHU. When you run a AHU, when you run a AC, there will be a condensation water. So that waste condensation water, normally in our previous days, we are letting as a waste. So if you account it, that's 900 liters per day, and operational wise, that is a huge impact. So by going by replacing the old conventional type of AHUs into a electronically communicated EC fans installed AHUs, that will save the water conservation. This is the chiller. So I'm just referring to chillers also in terms of water utilization and conservations. I'll take our own industry example. 3 years before, we were using a water cooled chiller. The water cooled chiller were using around 30 kls per month, 30 kiloliters per month water consumption. Now we have completely eliminated with the air cooled. Means I don't want to save any water. Complete elimination means now instead of water cooled, we have moved to air cooled temperature, air cooled AHU system. So this is related to brazing process. Brazing also involves water, that is waste. One of the industry, they also pointed to wherever they have an opportunity to reduce, and by this their daily consumption has reduced from 25 kl to 6 kl. This is quite common. You might have seen in every places or few places, aerator or the echo nozzles. Wherever you fit echo nozzles, I don't know about this campus, but most of the industries, most of the commercial places, they will fix this aerated or echo nozzle only to conserve the water instead of letting the amount of water to be wasted. It will serve the purpose but also save the water. This is a canteen dishwasher. Instead of manually cleaning, industry has adopted dishwashers. Dishwasher means less water consumption. With the water mist, they can clean the utensils or the plates, which is much more better quality and with hygiene also. This is also one of the water conservation at ETP. Instead of giving to drying bed, means allowing to naturally dry, they have installed the screw pumps, so the dewatering pumps. So dewatering pumps that will dewater, and the wastage can be used as a manure instead of wasting out. This is the rainwater. Rainwater is most because it is naturally available. As a nationwide, we are not matured enough because the average rainfall it remains same. It is happens in first quarter or fourth quarter. The rainfall is coming, but as a industry, as a nationwide, we are not maintaining well. But these are some of the best practices. Industry they will now manage the rainwater for their purpose, for the land use or the gardening purpose. It can be a open pond type. It can be a runoff water. Can be stored in the concreted water, leak-proof concreted sumps, and can be treated and can be used for their urinals or the restrooms. This the treated water they are using for their garden development. So means basically STP or ATP treated water. After treatment, by ensuring the quality parameters, they are utilizing for land usage. This is related to energy conservation. Energy means UPS systems. So IT, wherever IT systems are there, they will use a lot of batteries for the ITs, though it is the savings in terms of energy. And naturally available solar also. The roof systems, wherever you can install, even at home, you can at the offices buildings, even at the industrial premises. So you can get the maximum benefit for hot water and also for the energy reduction. This is similar to industry applications. One is solar panel, another one is the integrated BMS systems, and also on the biogas plant and EV charging systems. Nowadays, EV vehicles are more. Now charging points are required even for the campus, even for the industries, even for the commercial setups. So by utilizing the natural energy, the energy can be utilized or can be further modified for the beneficial. This is related to waste management. Means the STP waste after dewatering, it can be used for gardening instead of just dumping as a waste, or it can be a municipal waste also. Suppose if it is a municipal activities. In the food waste management, this is the initiative reducing sorting out of the food, basically the degradable, non-degradable, and also allowing for composter and getting the compost and giving it for the land use for local villages, also for the internal campus premises. So with this, I conclude my session. What we can recap on this environment audit or the green audit is basically whatever our interaction relation with the environment, we have to do in such a way that sustainability manner. We have to reduce our consumption records, and also the best practices should be adopted. It is not limited, even if it is industries practicing, it cannot be for organizations or for the institution. It can be. So that's how the best practice should be cross-learned and adopted and implemented. And long-term benefit, obviously it is there. Tangible, intangible benefits in terms of cost that will come over a period of time. But direct benefits, you will have a better, sustainable manner practices, and also you will give that will give a branding or image for the industry or for the institution as well. As a future leaders, wherever you might start your work or are already in the work, probably you should also emphasis on these practices. Mutually class learn each other from industry to industries, or from organization to organizations, or from the different platforms. Like these seminars, workshops will help us to make a better future. With this, I somebody PDFs. I've shown the industrial practices, but the green audit is also the university is also practicing PDF one. I just want to run through. I'll not go in detail. A PDF one. PDF. Close, ಮಾಡಿ open ಮಾಡಿ.